welcome. I am very excited to be a part of the Techno Day conference, especially on International Women's Day, and to speak about one of my favorite topics, debugging. My name is Sabina Smajlaj, and I am an operations developer at Hudson River Trading. I have spent my career working with high-impact critical systems. I started my career at JP Morgan, where I first built technology for our energy sales and trading teams. These systems needed to evaluate risk and see positions in real time in order to make trading decisions for a team that was handling billions of dollars. They also needed to provide up-to-date information on existing clients or potential new clients as soon as possible. When I joined in 2016, the price of crude oil was the lowest it has been in over 2 decades. So having our system go down or show incorrect information, even for a few hours, was disastrous. Then I moved to work on the internal technology platform that was used by every technology team in our macro trading business, which included over 1,000 developers. Our development environment at JP Morgan was as agile as it gets. As soon as a code change was ready and accepted, it was automatically pushed into production. This meant that if we accidentally pushed a bug into production, thousands of developers all over the company would be impacted, and a system that handled hundreds of billions of dollars was now not working. After JP Morgan, I moved to Hudson River Trading, which is a high-frequency trading firm. What did this mean? This means that I am now responsible for creating monitoring software for a system that executes billions of trades every day at the microsecond level. A bug in our production environment, even for 15 minutes, could mean we have lost hundreds of millions of dollars. And again, at Hudson River Trading, the development cycle is as agile as they come. Anyone can make a change and it goes right into production. Working on these types of critical systems have taught me a few things. First, I will talk about what it means to write code with debugging in mind. Then I will talk about how to think through your approach when you're debugging. And lastly, some helpful tools and techniques for when you're debugging system failures in live. So what does it mean to write code with debugging in mind? We need to have good coding standards, descriptive logging, helpful tests, and then we need to understand the inputs and outputs of what we're writing in order to account for points of failure and to help build out systems that you can run in UAT or test mode. So what are good coding standards and why are they useful? Whoever is in charge of dealing with a failure, especially if they are new or unfamiliar with the code, will need to quickly understand and navigate the code base. So it's really important that we have good documentation at the module level, the class level, and at the method level. So whoever is looking at the code can quickly understand how the code is supposed to be used and what it is supposed to accomplish. Having type annotations whenever available are helpful in understanding what the code should be doing and understanding the flow without needing to have a debugger that walks through the code. Having consistency in naming, from variables to methods, class, and even modules and directories, will help someone navigate your code base and your environment as quickly as possible. And to this end, having a formatting library also aids in this. When everything is in a consistent format, it allows someone to quickly skim through code and understand it without needing to spend too much time on it. In addition, having descriptive logging makes it easy to track down a failure. If everything is written to a consistent location, if the logging keeps track of the state of your system and any changes to it, and if it catches and logs exceptions instead of letting them disappear, then the logs can tell you a clear story about what happened in your system failure. In addition, tests are an integral part of this. You need to make sure that you have both unit and integration tests, as well as having close to 100% test coverage. We know that 100% sometimes can be very difficult, but the more test coverage you have, the easier it is to understand which part of your system is failing. In addition, if you have mocks or hard-coded values in any of your testing, you want to make sure that you're documenting those. So when people are looking through the tests or running them, they understand what those values represent. The other really important part of writing code with debugging in mind is understanding the inputs and the outputs of the system that you are writing. This is useful first for being able to understand how your system can fail, and also very useful for being able to write a UAT version or a test mode version of your system that mimics production as closely as possible without actually impacting production. When you think about the inputs, these are points of your system that you cannot break or modify. So to truly test the system well, you want your UAT or test to mimic production inputs as closely as possible, or when possible, actually pull right from production since you can't modify the inputs. Then we think about the outputs. How do you verify the outputs without actually modifying your production? This is a good place to think about how you would create a scenario where you can run your system in test mode, which allows you to run the processes as if you were in production without modifying anything in production. This could look like a few various scenarios. Maybe you allow a user to specify a output file location where the outputs are writing so that they're not writing to production locations. Or perhaps you have already a test database that all of your test mode or UAT systems write to, or maybe the user can specify a test database that they want to write to. Or perhaps you have a UAT version of the next program that your system sends information to so that you can view that information in the order flow of your system. So now how do you think through what your debugging approach should be? Let's say there is a sudden failure in your system. You have an algorithm that is trading Brazil stock, but the source where the system gets its data from about our internal snapshot suddenly goes missing. So now you have a system that's making decisions based on zero information. Clearly, this is a massive system failure. So what is the first thing that we need to do? With any critical system, the first thing that you should do is determine the urgency and the impact. How quickly do we need to deal with this, and what kind of impact is it having on your code base, on your company? Do we need to shut everything down, or can we shut just one process down? And for whatever we decide to shut down, do we need to quickly bring a backup or a workaround to replace whatever that process was? If we go back to our Brazil stock example, if we are missing the source file for our internal snapshot, is there any other source that can approximate this information that we can now point our system to? And then once we have decided on an action, we need to think about and communicate the impact that this action will have. So now we've handled the most urgent part and can move on to debugging why the system actually failed. To do this, there are a few different approaches you can take. The first one is obviously looking at the stack trace. Some stack traces are more helpful than others. If you are lucky, you will see a very specific error message with a variable name or line number. The other important piece of information you can see here is the exit status. This could be helpful in showing you if it was an uncaught exception or an uncaught signal, such as a sig term or a sig kill. If the stack trace doesn't really clarify the situation, we might need to look at whether the error that we're seeing is an internal or external error. Does it look specific to perhaps an external technology that you're using? Or does it look like it's caused by something in your own code base? If it looks like an external error, then we need to consult a developer's best friend, the internet. If it looks like an internal error, then you need to see if you can walk back through the stack trace and find the bug in your code base. And this is where, if you're writing your code base with debugging in mind, it will make it that much simpler and more effective for you to look through the stack trace and go back to your code base. But what if the stack trace doesn't help you at all? The next step would be to check the logging of whatever process is failing to see if it can provide more context. Then, hopefully, there are tests associated with that process that you can run to see if you can narrow down the issue through a test failure. And this is where integration tests and especially unit tests come in handy, because if you run all the unit tests associated with your process and one or two of them are failing, then you can now narrow down the issue to the parts of the code that those two unit tests are specifically testing. The other option is, if you have a test mode or UAT version of your system that you can run this so that you have the opportunity to use more tools, such as a debugger, so you can step through the code and very specifically look at it. So now, what are some tools that can help make this process more efficient? Throughout the years, here are some of the ones that I have used in my various roles. Debugging dumpsters. What this means really is any type of tool that will give you a memory dump of the system when your error occurs. In addition, we have log analyzers. As I mentioned, going through the logs of the system to see what other context you can gain from it can be a really helpful step in debugging your process. However, depending on what system you're running, how big it is, what the log files look like, maybe doing that by eye is just not an option. And here you can use various log analyzer tools to help you parse through the log files in a more meaningful way. Another very helpful application are application performance monitors. And these help to identify bottlenecks in resources that could impact your application performance. At my various roles, a monitor that has been really helpful for us has been Grafana. It allows you to track different processes in real time and also provides very helpful GUIs and charts for you to quickly look at and analyze without needing to put in too much effort. And lastly, you have IDE or command line debuggers. And these are like whatever debuggers come with your Java IDE or your Python IDE, PyCharm, Visual Studio, whatever you're using, they will have a debugger with them that you can easily use to put breakpoints and walk through your code through there. Or maybe you're more of a command line person and you are more used to using GDB or IPDB for Python or C++ or C. And that, again, these are very helpful for if you have the opportunity to put break lines in your code and walk through your code. Another thing that people might not really know about are that there are GUI debuggers that are independent of your command line or your IDE that you can use and attach to your code. And maybe you're a more visual person, so you want a GUI debugger to help you walk your code. But the most useful tool that I have found throughout my experience has been, whether this is an internal or external tool, something that is always on, that is autonomous, that is independent, and allows for exception capture throughout your entire system. What does this mean? It means that it's running all the time. It means that your entire system communicates with this. It means that it's going to automatically catch exceptions. And it also has access and can observe your code base down to the deepest levels, which will make your stack traces and your logging more meaningful. And the most important thing is it allows you to view the true state of your code anywhere in the execution flow of an error. So that when you're looking at these stack traces, when you're looking at logging, this system will be able to tell you what the state of your system was when it failed. And so this might be what allows you to automatically figure out the issue and fix it in a minute instead of going through and trying to understand what the code base looked like at that specific amount of time, which could take like 30 minutes or it could take hours and could have a major impact. And hopefully this has provided some insight into how you can debug system failures and some tools and techniques that I have found useful throughout the years. Thank you.